Well, okay. Good afternoon to everybody who decided to join us for the seminar for Sano Seminar on Computational Medicine. We are now in the process of, let's say, people entering the room. So please wait maybe 2 minutes when room will be full, and then we will start. It will be, in the meantime, I would like to say that it will be the last seminar in this summer semester, and we will have something like a 6-week break due to, first of all, summer holidays, not only at Sano, but also at our collaborators. And also because of conferences which will take place in the end of August, beginning of September, especially it will be practically the whole first week of September will be meeting of VPH community in Stuttgart on and before this meeting we will have in Silico World project workshop for the whole day. So for these reasons we probably start in the second half of September. Well, now we have, I think, most of our participants. Yes, so I think that it is a time to start the seminar. So this seminar is from the cycle of talks given by PhD students at Sano, and today this PhD student will be Michał Motak. Michał joined Sano practically in the beginning of 2023, so Michał is conducting his research at Sano for something like 1 year and a half, so it is rather in just before middle of the time. So please take into account when you will see Michał presentation. And Michał has got Master of Science degree in biomedical engineering from AGH in Krakow. And now at Sano he is focusing on deep learning in robotic systems. And he is a member of health informatics team led by Przemek Korzeniowski, and Przemek is with us, so I think that Przemek is the right person to introduce Michał and also Michał research before Michał will start to present his research. So Przemku, please introduce Michał.
Thank you, Marian. So I guess you said most of it already. So Michał is a biomedical engineer, graduated from AGH, and his focus now is on medical robot, basically, because not a surgical robot, for autonomous ultrasound. So this is very exciting field because it combines like expertise that we have in our team, like work by Szymon Płotka in fetal ultrasound image analysis, with the collaborative robot that we have in our lab. So the idea for the project was to be like sort of driven by the simulation. So again, train first things in simulated environment, and then try to transfer it to a real world. Yeah, so that's what basically Michał is working on. And yeah, so I'm looking forward to his seminar. So Michał, please. Screen is yours.
Yes, Michał, please go on. And well, if you have urgent question, ask the question on chat or on questions and answers, and I will try to transfer this question to Michał. But however, after the end of the talk, there will be, as usual, a discussion. So, Michał, screen is yours.
Thank you, Marian and Przemysław, for the introduction. My name is Michał Motak. I am part of the health informatics team at Sano, and the topic of the presentation is robotic assisted ultrasound. I'm working in collaboration with Dr. Przemysław Korzeniowski, which is a team leader of my team, and Dr. Diego Dal Alba from University of Verona. As it was mentioned, I started on working on my PhD with the beginning of the 2023, and right now my project is like a pieces, like a puzzles, which I am trying to put together right now. And yeah, I've been working on few aspects of the RAUS project. So my research is a complex system called RAUS. I'm working on autonomous robotic system for ultrasound examination and usage of deep learning for robotic training and analysis of ultrasound data. The motivation of combining those technologies is enhancement of ultrasound diagnosis and image quality, mostly for the prenatal care, which is also field of our interest in health informatics group. So starting with the basics, diagnostic ultrasound is a diagnostic technique used to image anatomical structures. The transducer is usually placed on the skin. It emits ultrasound waves as well as detects echoes reflected back, and that's how we get the ultrasound image. As you probably know ultrasound is not invasive and safe. There's no exposure to radiation, which is crucial, for example, for monitoring pregnancy. Also, ultrasound is easily portable and cost-effective in comparison to other modalities like MRI or CT. And of course, ultrasound imaging is useful in variety of diagnostic applications in many medical specialties. So, as might be expected, every technology comes with its pros and cons, and this is also a case with ultrasound imaging. So what makes ultrasound training difficult and why we want to work on solutions, technological solutions for ultrasound imaging? First of all, image quality of imaging in ultrasound is worse comparing to other modalities. There are many noises, speckles, and artifacts caused by the nature of the sound wave interaction with tissues. Also, ultrasound is highly operator dependent. The quality of acquisited images rely mostly on the experience of a sonographer, and there is also lack of standardization in comparison to other modalities. CT or MRI have strict protocols resulting in more consistent image output. So all the above mentions mentioned factors make ultrasound training very difficult. Therefore, less experienced sonographers may perform worse quality examinations, which can lead to wrong interpretation and diagnosis. So there is a significant problem with lack of experienced sonographers in low and middle income countries. So as you can see, there's a big potential to bring modern technology into the medicine and look for solutions to this existing problem. So robotic ultrasound systems aim to overcome the problem by using the capabilities of robotic manipulators for ultrasound examination. There are a few main advantages of using such system for ultrasound analysis. First of all is high accuracy. So modern robotic manipulators are capable of performing very precise movements and also controlling the force on the human skin. Repeatability, which provides standardization into the whole procedure. Standalone systems require less or none of the human participation, and it depends on the type of the robotic ultrasound system, and increasing accessibility of ultrasound examination. So the diagnosis using ultrasound can be more available and can solve the problem that I mentioned. We can group robotic ultrasound systems based on the level of robot autonomy. The first group is teleoperation. The level of robot autonomy is low in this scenario, and the system depends on the expertise of the sonographer, but it brings very huge potential for the to perform ultrasound examination in many destinations without physical presence of the clinician. The next group is collaborative assistance. Those are semi-autonomous systems that are sort of help to the clinicians during the procedure. It can make the procedure faster or increase the accuracy of the diagnosis by suggesting simple tasks or analyze real-time ultrasound images, for example, during medical surgery or just a basic examination. And the last, autonomous systems have the biggest potential in this group because they can perform autonomous examination without any human interference, or in some cases just they need some actions from the clinician in the case of emergency or this kind of aspects. From now, we will mostly focus on the autonomous systems because, as I mentioned, they have the biggest potential to solve the problem. And also those systems do not require any human operators to perform ultrasound examinations. There are many applications of these systems. For example, ultrasound image acquisition, 3D image reconstruction, which is used for before pre-operative and during the operation, and also image quality improvement and real-time analysis of the ultrasound image during the procedure. There are a few technical problems that need to be solved. For example, trajectory planning. So how to make the system to plan the trajectory that it has to go along during the procedure to perform the examination with the highest accuracy possible. The probe positioning is also very important because in every ultrasound examination, there can be different ways to position the probe on the human skin with the proper force on the skin, proper angle or slight movements. This is the hardest part of the ultrasound robotic systems. And now looking at the diagram on the right, we can split a typical autonomous ultrasound robotic system procedure into 3 parts. Before the procedure, during acquisition, and after the acquisition. So before the procedure, we can use external devices like RGB and depth camera to scan patient skin and to plan the trajectory. Also, we can use preoperative medical image from other modalities, which can also affect the planning and the evaluation after acquisition. During the acquisition, robot with attached ultrasound probe move along the planet path, gather ultrasound data and analyze them in real time. And the results of this analysis can modify and update the planet path before the procedure in order to acquire better quality images. And finally, after the acquisition, we can evaluate our system using the planet path or using the preoperative medical image. There are 2 examples of robotic autonomous ultrasound systems. As you can see, there are a lot of aspects. Of course, the robot arm, RGB depth camera, force sensor to control the force on the human skin, and in some cases, ultrasound phantom for the testing of the system. Now, let's move into the deep learning part in my project. So the technology development in the field of robotic systems has been ongoing for many years. But as with other research areas, artificial intelligence changed everything, bringing completely new methods and possibilities to the robotic systems. As you can see on the chart, from the meta-analysis, the number of papers on robotic assisted imaging systems increased after around 2015, and most of the current papers also regard ultrasound imaging above other modalities. This presents the current trend in robotic systems for medical imaging, and at the moment, deep learning is the best way to train autonomous intelligent robotic systems for medical imaging. Going to the technical details, reinforcement learning is a current approach to train autonomous robotic systems. We are using deep learning methods to train the agent to achieve specific goals in the best optical way. And this is the ultrasound examination in this scenario. We are using virtual realistic simulation environments to give the robot a sense of very realistic scenario and to get the best results from the training. The agent, which is the robot, takes actions with simulation environment and gets feedback as a reward function, which is meant to be maximized. There are a lot of existing reinforcement learning architectures and methods. There are a few examples like deep Q-learning, deep deterministic policy gradient, and proximal policy optimization. So for the purpose of the path planning problem, I used a Python RoboMimic and RoboSuit libraries, which are using Mujoko physical engine to create the virtual realistic simulation environment. I trained the robots to move along prepared planet path, also ensuring that the orientation of the probe regarding the human skin object is optimal, and the constant force of 5 newtons is maintained during the whole procedure. Also, I tested another approach to robotic training, which is called learning from demonstration. This method aims to utilize recording from experienced sonographers and training robotic system to mimic the procedure based on the examination on the recordings from sonographers. It helps the system to understand the crucial details of some advanced examination cases that cannot be trained by the robot using standard reinforcement learning methods. So we can use learning from demonstration to train a robot only on the data collected from recordings of sonographers, but this will make the robot mimic 100% of the procedure, and it can have worse accuracy on or some new environment, new cases, and so on. But also we can use the recordings only to guide the robot during standard reinforcement training. So it will not only mimic 100% the procedure, but use the knowledge to adapt this during the training. And overall, the goal of the reinforcement learning training in simulation environment is, of course, transferring the knowledge to the real-world robot and test it on phantoms and on real patients in the future. And another application of deep learning in robotic ultrasound systems is post-regression. With usage of convolutional neural networks, we can predict the pose of the probe regarding the observing 3D data based on the actual ultrasound 2D image that is being acquisited in real time. The method can be applied in a bigger project for freehand ultrasound navigation and training simulators for sonographers. So I used Unity environment connected with Python to collect the data set. I loaded 3D ultrasound images and created a data set by randomly slicing the volume to the 2D ultrasound planes. The Python part was used for the training of the convolutional neural networks, And on the left, we can see an example of such architecture. It uses 2D ultrasound planes to train the model. And for the output, it estimates the position regarding the center of the volume, including the position and the rotation. This software will be effective in my future work because it provides source of data for neural network training, including navigation algorithms that move the probe on the volumetric data, collects the ultrasound data, and analyze them in real time. Another application is the navigation of ultrasound probe towards standard plane acquisition. Standard plane is a specific predefined view in ultrasound imaging that provides crucial medical information for diagnosis and interpretation. And for fetal imaging, there are a few different standard planes showed on the right of on the image. And one example of the probe navigation for fetal head standard plane is presented on the left image. It analyzes video sequence of freehand ultrasound examination, segments anatomical parts, and estimates actual pose of the ultrasound probe and measure proximity to predefined ultrasound, to predefined standard plane. The usage of this system is that it gives the real-time feedback about the accuracy of obtained standard plane. So during the ultrasound examination, obtaining the standard plane is the basic of the procedure, and this system can give real-time scoring of the actual obtained ultrasound standard plane in regard to the predefined standard plane that can give the best information to the sonographer and help with diagnosis and analysis of the ultrasound image. So for RAUS future plans, right now I've been working on different puzzles, different parts of the complex project which is RAUS. I had to learn the basics about robotic systems because I didn't have any expertise in this field before start of the PhD. So the application, one of the application that is in the future plans is teleoperative system using the equipment that we have in our lab at Sano. We have a lot of different equipment to create the system. Of course, it includes a robotic arm, a linear probe, ultrasound linear probe, RGB depth camera that can be used for planning of the ultrasound examination. Also VR Oculus Quest 2 and its controllers, but also other controllers like haptic device or 3D mouse, which can provide the best way of controlling the robotic arm to perform the ultrasound examination. We can use this system in many different ways. For example, using the VR goggles, the haptic device, and using this system, we can collect the data from experienced sonographers to use it for the purpose of robotic training and analysis of ultrasound images. And another part of my research, I would like to bring clinical value to the robotic project, because path planning, navigation, or probe positioning, positioning and regression are just technological problems right now. I don't see many publications that provide these clinical informations using robotic systems. So the way to do this is to use deep learning method for ultrasound image analysis, which can bring crucial clinical information for clinicians. There are very parameters for pregnancy monitoring and prenatal care, and also many organs that can be analyzed and diagnosed to enhance the prenatal care. So there are a lot of possibilities to use the ultrasound robotic systems, and each of these cases have of course its specific. So every approach must be different and specific for this case. So there are examples like baby weight prediction and calculations of the parameters showed on the left image. There's also parameter called angle of progression that I've been working on at the beginning of the PhD. And yeah, I used deep learning methods to estimate the angle of progression, which is one of the parameters that are very important before the delivery. And yeah, there are also a lot of applications on this image presented on the right. So thank you for your attention, and I'm looking forward to answer any questions.
Michał, thank you very much for presentation of what you have already achieved, and especially what is the most important are your plans. So, well, now I invite everybody to comment the research of Michał and ask questions. Maybe waiting on other participants of the seminar to ask questions. I would like to ask you to which extent something like simulation is important in your research. Are you going to build some tools for simulation, or are you going to just to use something what is available at that moment? How it will be linked with with robots which are already at the disposal of health informatic teams in Sano?
Yes, so right now I didn't test all the possible simulators. I was working mostly on this simulation using Python libraries and Mujoko engine. And this simulator is can be used to transfer the knowledge to the robotic system in our lab, but also the project that I showed in Unity environment. Right now, it's only focusing on the collection of the data from the volumetric ultrasound data, but it can be also enhanced with our robotic arm in this simulation in Unity. So in both cases, this can translate to the real world scenario. But yeah, there are two different problems and different problems and aspects to solve using those two simulators.
Well, but I think that these problems, it is something what could be a reasonable field of research, I think, yes. Well, we have on the list Jose Souza, a leader of one of teams at Sano. Jose, please go on with your questions.
Hi, Michael. Can you hear me?
Yes.
Yes, I can.
Okay, perfect. So yeah, thank you for the presentation. So I just probably it was my fault, but you described so a different set of techniques and environments that you explored, but I missed the point. So what, in terms of the research question, what is the problem that you are trying to solve? Okay, so in the end, you mentioned that you'd like to have clinical impact, and apply this in the clinics. But what is, so from that perspective, what is the problem that you are trying to solve? Is this, focus as, for example, Marian was saying, trying to use simulation to improve, the quality of the diagnosis, developing a robot arm that is able, to do it autonomously. And then I got confused in the end because you mentioned that you are going to develop an autonomous system, and then your future plans are all about teleoperations. So if you could, clarify me on that, that will be great. Thank you.
Yeah. So the navigation system. Sorry, did you say at the end you meant the teleoperation system or navigation system?
Yes. So I first of all, I didn't see, a clear research question about the problem that you are trying to solve. And then I got confused because you mentioned future plans here in teleoperation systems. And then at the beginning, you were saying that you are going to use deep learning and to develop an autonomous system. And also I'd like to understand what is the role of deep learning and the role of reinforcement learning on that process, because that's also not very clear for me.
Yeah, so the teleoperation system is just an idea to use all the equipment and to create the system, mostly to present it to the sonographers and to collect the data and test how sonographers are interested in using these systems, for example, for training simulators, and yeah, the other part was
well, we have some problem with hearing you.
sorry, I started to answering one questions, but there were like 3 others.
Yes. So the other question was about the research question. So you mentioned in the end that you'd like to apply this on the clinical, have impact on the clinical. But so coming from that perspective, what is the problem that you are trying to solve? So what would be, so a PhD should have a contribution. So you should extend a little bit what is known. So from what I saw here, you described very well the past, but I didn't see, how you are going to use that past to improve the future. So what is the research question that you are addressing? So
yeah, okay, now I understand. I think the main topic and the main contribution will be the usage of deep learning, because as I said, the topic of the robotic training has been ongoing for years, and there are a lot of research in this area. But now there are a lot of applications of deep learning. So the possibilities of analysis of images in real time can impact the training process. And it's a novelty that now it's being explored in this field, and other parts are just a part of the project that I'm exploring and learning all these new things. But yeah, the final contribution to the PhD will be focusing on the deep learning parts of the robotic training. Maybe not only the reinforcement learning, but focusing especially on the impact of the deep learning image analysis during this training, because we can calculate a lot of parameters and things during from the ultrasound image, and we can connect it into the reinforcement learning part to achieve better results for specific medical cases, not only for the basic movements of the robotic system. I hope it's clarify.
yeah, so now it's clear. So mainly what you want to do is to capture, to enhance or to improve the images that are possible to be done. Yeah, and then you are going to use that into a deep learning environment to do something else. Okay, so this is just an acquisition of data. So if we're putting that in a simple way. Okay, yeah, thank you.
Okay, now we have Wiesław. Wiesław, could you please go on with your question?
Hey, thank you, Marian. I have a few questions. Maybe I start with the first one. How many ultrasonic procedures have you observed? Can you hear me?
Yeah, like in real life, observing the.
Yeah, in real life, how how ultrasonographers examine patient what are their movements, how they look at images and so on. Have you done it?
Not yet. I didn't.
Do you plan to do it?
Yeah, of course. I think
Because
it's
how
yeah,
otherwise you are trying to help those people if you don't know how they work, what they need, what they expect. Otherwise, whatever you do might be completely misaligned with whatever they want. So this would be my first recommendation. You mentioned at the beginning that there's difficulty in training of ultrasonographers. I wonder, can you justify why interpretation of ultrasonography is more difficult than interpretation of MR, where you have numerous pulse sequences and you need to take most of them to make diagnosis?
Yeah, so as I mentioned at the beginning, of course, there are the quality of the ultrasound image is worse in comparison to other modalities, but also the interpretation of ultrasound data is in real time. So the sonographer have to analyze the data at the moment, not like MRI or CT that the image was acquisited in the past, and the radiologists have time to look at the image and interpret it. Also, very important problem in ultrasound is the movement of the human skin based on the part of the body that we want to observe. There are movements from breathing, so this is another aspect, and I think that every person without any expertise know that the ultrasound image is very, very chaotic. It changes really quickly. There are a lot of artifacts, so it must be also more difficult for sonographers to interpret these images than for radiologists to interpret MRI, for example.
Okay. Another question is, have you done the state-of-the-art search in your field? Because you are saying, oh, what is new? I am using deep learning in ultrasonic robotics. If you go to PubMed, you have 350 publications in this topic. How your work is novel. Have you done any state-of-the-art review? Can you identify your own niche, that whatever you are doing is novel and you are not redoing things which are already done?
Yeah, so the deep learning aspect and especially the analysis of the ultrasound image might be a novelty because, as I mentioned, the research on this topic was ongoing for many years, but now the deep learning part is more common and appears in many publications right now.
So how you are different? What novel component do you propose?
So I didn't present my work and my novelty in the presentation. So this is the future in front of me to find
at this stage, yeah, but at least if you do, a solid state-of-the-art analysis and see what has been done, it will be easier to you to define what do you want to do in the future. So this is another recommendation. Then another issue, you are talking about path planning and navigation. What do you have in mind? Can you be more tangible what you have in mind? Because again, if you look at any sonographer, first he or she positions a probe at certain location. Second, she basically determines some angulation. Third, he or she basically applies some pressure depending on the situation. So how your navigation, robot navigation or path planning is going to be related to typical actions of sonographer?
Okay, so starting, thanks for the recommendation at the beginning. So right now the state of the art and the for example this solution for the navigation is a very new approach and new publication. So this is part of my state of the art research, and this shows the potential of deep learning and the current trends in usage of the deep learning. And yeah, this also connects with your another question regarding the navigation system. So as I mentioned, of course, every case, every medical procedure and observation of different organs differ very much. It's based on just the place on the body and even the parameters of the person, of the patient. So for example, the human from demonstration is a method to bring the specific movements of the probe for this specific medical application, because it's impossible to train the robot to perform all the types of examination in the same with the highest accuracy. So this is the future, to focus on some clinical aspects and to tune my algorithms, my work, my solutions to the specific case.
Yeah, you mentioned that your future work will be measuring performance and comparing robotic solution with ultrasonographer. I think this is a great point. Do you have some idea how do you want to achieve it?
So to collect the data from sonographers or on some phantoms at the beginning, to see how they perform the examination, using, of course, the robotic system and different controlling devices to sorry, to see the difference between the usage of different controlling devices, and then we can compare this with robotic system that can mimic the ultrasound examinations without human interference.
On the list of your future project, you have also image analysis using deep learning. It's the same story. There are thousands of papers on the topic. So please, if you want to do this part, do state of the art and be sure that whatever you decide will be novel. And the last question is, why don't you consider any safety? Because this is critical in any robotics applications.
Yeah, so starting with the first part, of course, there are a lot of research in usage of deep learning for medical image analysis, but they are used to measure some parameters and to bring the clinical value, but there are I didn't see too many publications regarding the usage of the actual analysis, the calculated parameters to navigate the robotic learning.
I mentioned that there are 350 on PubMed, and regarding ultrasonic deep learning analysis, over 6,000 papers. So again, it's a huge, huge field. And if you want to do something novel of having value, please first understand what others have done and identify a place for you.
Yeah.
And
Okay.
safety, because you haven't addressed the issue of safety. How do you want to do it?
Yeah, I didn't mention the safety requirements of the procedure, but it's connected with the part of the movement of the robotic arm in a simulation environment. So this is the standard way to check if the force of the robotic arm on the human skin is in the safety range to ensure the safety of the patient.
So good luck. You have a very nice topic. I hope that you enjoy it and do something novel. Thank you.
Thank you very much.
Many thanks. Many thanks for this discussion and many thanks for for advices, which are, I think, very important at this stage of research. Przemku, would you like to add something to the discussion which was up to now, or?
I'm afraid I need to run because I have another call at 3 with University of Leiden. But yes, so just to very briefly summarize. So we are looking at gathering all the data, so not only imaging data, but also all the angles, positions, but also forces and torques. We'll see how it goes in practice on real patients. Initially, we would like to do the fetal medicine, but this in practice might be problematic, especially like testing maybe at some stage, although it's sort of non-invasive system, but I guess it would be problematic testing it on pregnant women. So we'll see how it goes. So we would like to finalize building the hardware, then the data acquisition, and then hopefully working with help of Szymon and other team members on the deep learning aspect, because we know it's a huge topic now in terms of simulation. That we are also will be exploring aspect of generative AI. So basically, currently we are using volumes, like a 3D volumetric scans, which are relatively easy to obtain, but they are not really high quality. but we would like to improve them with generative AI in order to get more data with time.
Many thanks. I would like to thank very much Michał. Well, Michał decided to present his research at this stage, which is, from my opinion, it was a very clever decision. But in order to make such a decision, you need to be, let's say, brave enough to do this, because the research which were presented in previous talks of our PhD students were research after at least 2 years of research and many discussions. So I think that this discussion, and especially contribution of Wiesław Nowinski to this discussion, will be fruitful for the future. And I hope that Michał, you will stay also with Wiesław in contact, to get some additional advices besides of what you will hear from your supervisors, Przemek and Diego. So many thanks for presenting this. Many thanks to everybody who decided to be at our seminar. And as I told at the very beginning of today's seminar, we will meet in the second half of September. Most probably the first seminar will be on 16th of September. So have a good time during your summer holidays. Thank you very much and goodbye.
Thank you.